Welcome back. This is Nick Agram once again. I will give some examples of the unit circle and the 6 trigonometric functions. For example, use a unit circle diagram to find the values of cosine negative 270 and sine negative 270. And we know that it is negative 270 is there, that is negative 270, and that is similar to 90 degrees, coterminal of 90 degrees. So as we can see here, we have the y value, this point, we have cosine theta and sine theta. That means our x value is 0 and our y value is 1. So cosine negative 270 is equal to 0, and we have the sine negative 270 is equal to 1, as you can see there. Okay, we're going to continue, find exactly the possible values of cosine theta for sine theta is 2/3. So we have our y value is 2/3. How about 0.16? If we can put there, that is our theta. And here our x value we don't know yet. That's we call it x. And our y value is 2/3. Okay. So since this is a right triangle, we can use Pythagorean theorem. We have x squared plus 2/3 squared is equal to c, that is 1 squared. If we can put now our x here is cosine theta and our y is sine theta. So if we can put cosine theta, the square of that, plus 2/3 squared is equal to 1. And then we have cosine squared theta, or that is the square of cosine, not the angle to be squared, the cosine. And then we have 1 minus, if we subtract both sides of the equation by 2/3, parenthesis squared, 2/3 parenthesis squared, then we have 4/9. Then we have cosine squared theta is equal to 5/9 if we expand this so that we have the same denominator, and then we will get the square root of both sides of the equation. Then we have cosine theta is equal to the square root of 5 divided by 3. If I'm going back to the figure, you can see here that my y is the same here also. This is also the y value of this is 2/3, and the x value here is negative, as you can see there. So there are two values of our cosine theta. Our cosine theta is also negative square root of 5 and 3. Our x here have two values. Okay. How about values of cosine? Before I'm going to leave this example, as you can see here, I use the Pythagorean theorem. I use x squared plus y squared is equal to 1. That's a Pythagorean theorem. But our x is the cosine squared theta plus our y is sine squared, not to there, squared theta is equal to 1, or 1 squared if you want. This is a very important identity. So the square of cosine plus the square of sine is equal to 1. Very important identity. Okay, let's go to the next example. Find the possible exact values of sine for cosine 4/5. So our x value is 0.8. So here we go. There you go. And this is our theta, cosine. This is, we have x is 4/5. And then we're going to find sine theta. That is what we're going to find. I'm going back here again. We're going to use this identity now. That is cosine theta squared theta plus sine squared theta is equal to 1. Or if we simplify, we want only sine this time. Then we have sine squared theta is equal to 1 minus, if we subtract both sides of the equation by cosine squared theta, then we have cosine squared theta. And then if we want to find now sine theta is equal to the square root of 1 minus, what is cosine theta? That is 4/5 squared. So we have square root of 1 minus 16/25, and then we have sine theta is equal to the square root of 25 minus 16, that is 9. If we expand this by 25 minus 16, that is 9, then 25. Then we have 3/5 sine theta. Okay, that is for the first part. But you know also that our x is here. There you go. So this is also our theta. So we have sine theta is equal to 3/5, but here also it is negative 3/5, because here this is also 4/5, but our sine theta there is negative 3/5, the y value. Should be 0.6. I used the wrong value. I'm going to draw better so that you can see it. It should be here. There you go. And it should be here. There you go. That's theta, and that's theta. There you go. 4/5, and we have negative sine theta there, which is negative 3/5. Okay, I'm just going to prepare for the B, and then I will solve it later. I will pause. Let's continue. Our cosine is negative 3/4. So we have negative 3/4 here. There you go. That means it should be there. And it should be, I will use another. It should be here. That's it. So this is our theta, and this is also our theta. Okay, so if we have, this is a unit circle, so this is 1, this is 1, of course, you already know that. Okay, so our coordinate here, I will use red. This is negative 3/4 and sine theta. And this is positive, sine, the y coordinate is positive. And here is negative 3/4 and negative sine theta. So we have two values. The identity, cosine squared theta plus sine squared theta is equal to 1. I need sine, so I have sine squared theta is equal to 1 minus cosine squared theta. Then we have sine theta is equal to positive negative squared of 1 minus cosine squared theta, because we have two values as we saw there. Okay, so that means we have positive negative squared of 1 minus the square of negative 3/4. Then we have positive negative squared of 1 minus 9/16. Positive negative. Then we have 16 minus 9, because we have here 16 there, 16. That is 7, 16. So we have positive negative squared of 7, 16. So our sine theta there is squared of 7. I have, sorry, not 16. That's 4. That's 4. Okay. The next one, the C, we have cosine theta is equal to 1. That means here we have 0, 1, 0. Our sine, we know already there. So that means we can prove it. We have sine theta is equal to square root of 1 minus cosine squared theta. Then we have square root of 1 minus cosine is 1. Squared is still 1. So we have 0 sine theta. So sine theta, when cosine theta is equal to 1, sine theta is 0. Okay, the next one. Here, cosine theta, we can use this one already. Cosine theta is 0, that means 0, 1. We can prove that also. Sine theta is equal to the square root of 1 minus cosine squared theta. We have square root of 1 minus 0, and that is 1. I forgot to tell you that this is also 0 and negative 1. So we have positive and negative there. So positive, negative 1. So when cosine is 0, we have sine theta is equal to positive and negative 1. Okay? That we're finished with that. In my next video, I will be discussing this type of problem. Find cosine and tangent when sine is given, and we have a limitation. That means theta is from 180 to 270 if you put that in degrees. Okay, see you there. Thank you for watching, and please subscribe if you want to see more. Thank you. Have a nice day.